Okay, good morning, my dear students. So now we are discussing about the assignment, fifth assignment questions. Okay, so the this question is solve the ordinary differential equation, that is ODE, given below to find y of 2.0 to using modified Euler's method. Take h is equal to 0.01 and y of 2 equal to 2, where the ordinary differential equation is e raised to y dy by dx is equal to 17x. Okay, so this one is given. So first we have to modify this one into dy by dx equal to f of x comma y. Then here the initial condition is given, y of 2 equal to 2 means x0 equal to 2, y0 equal to 2. H is given 0.01 and we are asked to find y of 2.02. So please note, as h is equal to 0.01, first we have to find y of 2.01, then we have to find y of 2.02. So given dy by dx is equal to 17x e raised to minus 1. Please note, actually we have e raised to y dy by dx equal to 17x. So that e raised to y is shifted to right hand side. So we have dy by dx equal to 17x e raised to minus 1. So this part is f of xy. So f of xy is equal to 17x e raised to minus 1. Now also given x0 equal to 2 and y0 equal to 2. And we are asked to take h is equal to 0.01. Is it okay? So if h is equal to 0.01, then what is the next value of x0? That is x1 is equal to x0 plus h, that is equal to 2 plus 0.01, that is 2.01. Is it okay? So now, what is f of x0 comma y0? Because x0 is given, y0 is given, then by substituting x0 and y0, what is f of x0 comma y0? F of x0 comma y0 is 17 x0 e raised to minus y0, that is equal to 17 into x0, that is 2, into e raised to minus y0, that is e raised to minus 2. So this value is 4.6014. F of x0 comma y0 or f of 2 comma 2 is equal to 4.6014. So now y1 is equal to, first we have to apply Euler's method. So what is Euler's equation? Y1 is equal to y0 plus h into f of x0 comma y0. So that is equal to 2, y0 is 2 plus 0.01, that is h, into f of x0 comma y0 is 4.6014. So 2 plus 0.01 into 4.6014, that is equal to 2.046. So by applying Euler's method, y1 is equal to 2.046. Then we are going to apply the Euler's modified method. So before applying Euler's modified method, we have to take y1 as the y1 given by Euler's method. So we have to take that y1 as y1 of 0. Okay, means 0 to y1 value of modified Euler's method. So now we are going to apply modified Euler's method. So first we have to find what f of x1 comma y1 of 0 into this equation f of x comma y equal to 17x e raised to minus y. Substitute x1 is equal to 2.01 and y1 is equal to 2.06. So we have 17 into 2.01 into e raised to minus 2.046. So what we have? F of x1 comma y1 of 0 equal to 4.4165. This is f of x1 comma y1 of 0. So now as per modified Euler's method, y1 of 1 is equal to, as per by applying modified Euler's method, y1 of 1 is equal to y0 plus h by 2 into f of x0 comma y0 plus f of x1 comma y1 of 0. This is modified Euler's method. So we have 2 plus 0.01 divided by 2 into, what is f of x0 comma y0? F of x0 comma y0 is 4.6014 plus f of x1 comma y1 of 0 is 4.4165. So the answer is 2.0451. y1 of 1 is equal to 2.04y1. And we can see that this y1 value is, so now this one is the current value. This current value is not equal to the previous y1 value. These two are different. So we have to continue our, we have to apply again the modified Euler's method. Apply again the modified Euler's method means again we have to find f of x1 comma y1. So what is that? F of x1 comma y1 of 1, f of x1 comma y1 of 1. Now we are substituting this value because this one is the latest value, right? So f of x1 comma y1 of 1 is equal to 17 into 2.01, that is x1. This x, we are substituting x1 into this x. So 2.01 into, now y1 of 1. y1 of 1 is e raised to minus 2.0451. So the answer is 4.4205. 4.4205. This is f of x1 comma y1 of. Now again find y1 value using Euler's modified method. So we can label it as y1 of 2. So y1 of 2 is equal to y0 plus h by 2 into f of x0 comma y0 plus f of x1 comma y1 of 1, this y1 of 1. So equal to 2 plus 0.01 divided by 2 into 4.6014 plus 4.4205. So the answer is 2.0451. y1 of 2 is equal to 2.0451. That is exactly equal to the previous value. So we can stop our execution of this program. So we can take y1. What is y1? y1 is the value of y at x equal to x1. That is at x equal to 2.01. The value of y is 2.0451. So we can write it as y of 2.01 equal to 2.045. Is it okay? So now by using this value we have to find y of 2.02. Is it okay? So that we are going to do. So again please note the ordinary differential equation is dy by dx is equal to 17x e raised to minus y. F of x comma y is equal to 17x e raised to minus y, that is f of x comma y. Now the new initial condition is x1 equal to 2.01 and y1 is equal to 2.0451. The previous answer is the initial condition of new execution. Now what is h? H is equal to 0.01. So now what is the next value of x1? x1 plus h. So x2 is equal to x1 plus h, that is equal to 2.01 plus 0.01, that is equal to 2.02. So this is new x. Okay. So now what is f of, so we are starting new execution. So this is the initial condition. So what is f of x1 comma y1? F of x1 comma y1 is equal to 17x1 e raised to minus y1, right? This will become x1, this will become y1. So what is that? That is equal to 17 into 2.01, this value, into e raised to minus 2.045, e raised to minus 2.045. Why we took x1 and y1? Because we are going to apply Euler's method. For Euler's method, we require f of x1 comma y1. Please note, now x1 and y1 are the available data, not the new data. In previous execution, x0 and y0 are the available data, that is initial condition, and we are finding y1 corresponding to x1. Here, now we are starting the next execution where x1 and y1 are the initial value for that execution. For available data, x1 and y1 are the available data, and we are going to find y2 corresponding to x2. So please note that. So for that purpose, we require f of x1 comma y1, that is equal to 4.4205. So now apply Euler's method. So by applying Euler's method, we can find y2. So what is that? y2 is equal to y1 plus h into f of x1 comma y1. So please note these terms. If you are finding y2, here we have y1 and here we have f of x1 comma y1. If you are applying Euler's method. In previous execution, this is y1, this is y0, and this is f of x0 comma y0. Because at that point we are finding y1 using x0 and y0. Here we are finding y2 by using x1 and y1. So what is y2 by using Euler's method? That is equal to 2.0451 plus 0.01 into 4.4205. So this is equal to 2.0893. So y2 is equal to 2.0893 by using Euler's method. Is it okay? Now we are going to apply the modified Euler's method. So please note, we are going to use the modified Euler's method. So for that purpose, this y2 is labeled as y2 of 0. Okay. So now, for Euler's method, what we require? We already have f of x1 comma y1. Now for modified Euler's method, we require f of x2 comma y2. x2 is a new point. We need the function value, f value corresponding to the new point. If you are applying modified Euler's method. So what is f of x2 comma y2 of 0? F of x2 comma y2 of 0 is equal to 17 into what is x2? 2.02 into what is y2 of 0? y2 of 0 is 2.0893. So we have e raised to minus y2, right? So that is e raised to minus 2.0893. Means for this one, this term will become x2 and this term will become y2 of 0. Is it okay? So f of x2 comma y2 of 0 equal to 4.2504. Now apply modified Euler's method. So what we have? We have y2 of 1, the new value, modified value. We are modifying y2. We already have the new value y2 and we are modifying that new value. So what is the modified value of the new point? That is y2 of 1 is equal to y1 plus h by 2 into f of x1 comma y1, that is corresponding to the available point, and f of x2 comma y2 of 0, the new point where we require a modification. So f of x2 comma y2 of 0. So this is equal to 2.0451 plus 0.01 divided by 2 into 4.4205 plus 4.2505. So this is equal to 2.0885. y2 of 1 is equal to 2.0885. And we can see that the modified value of y2, that is this one, is not equal to this one, the previous y2 value. So we have to continue it. Okay. So if you are continuing this, we have to find f of x2 comma y2 of 1, right? So f of x2 comma y2 of 1 is equal to 17 into x2, that is 2.02 into e raised to minus y2 of 1. Now we have to use this one, e raised to minus 2.0885. So what is this? F of x2 comma y2 of 1 equal to 4.2538. F of x2 comma y2 of 1 equal to 4.2538. So now again apply modified Euler's method. So what is the modified value of y2? We can label it as y2 of 2, that is equal to y1 plus h by 2 into f of x1 comma y1 plus f of x2 comma y2 of 1. Okay. So equal to 2.0451, that is y1 value, plus h by 2, 0.01 by 2 into 4.4205, that is f of x1 comma y1, this is fixed, this body is fixed, plus f of x2 comma y2 of 1, 4.2538, this one. So what we have, y2 of 2 is equal to 2.0885. y2 of 2 equal to 2.0885. And we can see that this modified value of y2 is exactly equal to the previous value of y2. So we can stop here. So what is y2? Now we can say y2 is equal to 2.0885. And what is y2? y2 is the value of y at x equal to x2. x2 is 2.02. So we can write y of 2.02 is equal to 2.0885. y of 2.02 is equal to 2.0885. And please note, we are asked to find y of 2.02. We are asked to find y of 2.02. So this is the value. Y of 2.02 is equal to 2.0885. Okay.